talk to you about choosing an infrastructure as code solution. And you may have already decided that you know what infrastructure as code solution you're going to use. But what I'm going to do is talk a little bit about why you might consider what that looks like for your organization. So first of all, I'll introduce myself. My name is Lee Briggs. Before I had my current role, which was which I'll talk about in a few moments, I spent 10 years as an infrastructure engineer. So I used every infrastructure as code solution you could think of. I even built one myself at one point. And I also built a very large platform for a Fortune 500 company. So felt a lot of the pain that I think is trying to be solved by cloud native solutions at this point. I have an account on Elon Musk's playground on Twitter. I also write fairly frequently on my blog, which is there. So that's a little bit about me. What we're going to talk about today is infrastructure as code and configuration management. We're going to define some things. I'm going to take the opportunity to give my perspective on the differences between imperative and declarative. I'm going to talk about how infrastructure as code tools work. And then once we have an understanding of how they work, we can start to look at how you might look at them through a different lens. And then finally, we'll talk about how you would decide if you would choose a different way. I will say that my current role is in software sales. My intent here is to not sell you anything. If you accidentally feel compelled to buy something at the end of this, that is an accident. I didn't do that on purpose. But my job is in software sales. I'm now a sales engineer. But my intent is to not sell anything to anybody. So I think we need to define what infrastructure as code is, and I'm going to start really, straight off the bat with a hot take, and I put code in inverted quotes here because, my personal opinion is that the definition of code is very flexible when it comes to infrastructure as code. But when I started in the industry, infrastructure looked like this, and this is not an actual photo of my home lab, but it's a fairly accurate representation. But we spent lots and lots of time buying servers, building data centers, putting servers in data centers. And there is a little bit of a groundswell around going back in this direction because of the cloud providers charging you lots of money. There's a reason we went away from this. And the reason was because you could provision infrastructure at the click of a button. You didn't have to wait 6 weeks for a server to turn up in a data center. You didn't have to have expertise in networking. You didn't have to hire an army of people. You didn't have to deal with supply chain issues. I don't know if anyone's tried to order and stack a data center recently, but it's really, really hard. So cloud providers are here for a reason, and they're not going anywhere. Regardless of the latest blog post from the Ruby on Rails guy saying that we're all going to get out of the cloud in 5 years, it's just not going to happen, and for reasonable reasons. But before we had all these API-driven ways of provisioning infrastructure, we would rack a data center, and then we would install an operating system, and then we had to manage all of that stuff, and we used configuration management to do that. So Puppet, Ansible, Chef, CF Engine back in the day were all configuration management tools. And then we created this subset of those configuration management tools as infrastructure as code solutions that have slight differences between configuration management and infrastructure as code. So configuration management tools can be declarative or imperative, whereas infrastructure as code tools are nearly always, in fact, they are always declarative. Configuration management tools generally interact at the operating system layer, and infrastructure as code interacts with an API. If you are a user of Civo Cloud right now, you can use most infrastructure as code tools to provision things in Civo. And then most importantly, there is an underlying principle that drives infrastructure as code solutions, and that is the DAG, which I'll be talking a little bit more about in a few moments. But that DAG is a directed acyclic graph, which is created to create representations of all the things that you're managing. And then you store the results of that DAG in a state store. Almost every infrastructure as code tool does this. Some of them expose that to you, some of them don't, but they all do this. And that is how you can really have a clear definition between infrastructure as code and configuration management. As I already said, all infrastructure as code tools are declarative. That doesn't mean that you get to go to the cloud provider API and say, give me this infrastructure, although I did see the Civo announcement earlier today, which is basically they've decided that this is going to be a track they're going to take, which I am a huge fan of, because we're now pushing towards this mechanism in which instead of having to manage all the resource graphs yourself, the cloud provider is going to do this for you. I know a lot of people at AWS, they're never going to be able to do this because it's essentially just a Rube Goldberg machine that an army of people manage, but newer cloud providers have got the ability to be able to say, we want to have this declarative thing. So this is the infrastructure as code tool's big value proposition, that they're going to allow you to say, I want the state of the world to look a certain way, and you are going to figure out how we get to that. And that's a really important thing, because infrastructure as code has these two things that are super important. They have the declarative mechanism, and they have this DAG, this directed acyclic graph. And I have arguments with people on the internet all the time, for some reason, because I have nothing better to do, about arguing what imperative and declarative actually means. And I've tried to make my best guess at a differentiation between these two things. When you are making the decisions about the order of operations when you create things in your cloud provider, you are following an imperative pattern. So if you've ever used the Civo API or the AWS API or the Google Cloud API and used their core SDKs, so like their Python SDK, you will decide that in order to create a network, you have to create this, and then you have to create this, and then you have to create this. And that happens in an order that you decide and you choose. In a declarative pattern, you basically say, I want to create these 5 things, and it happens for you. You don't have to make any decisions. You don't have to catch exceptions and say, well, if that thing failed to create, then this thing shouldn't create, because they are related to each other. That's really, really hard to do on your own. I've tried to do this before, where we built this kind of platform as a service thing with the underlying AWS Go SDK, and it's a really, really difficult pattern to follow, and it was thousands and thousands of lines of code. If you do this in a declarative manner, it's completely condensed. So how do you do it in a declarative manner? Well, this is the difference between the AWS, doing this in a declarative manner with the AWS API, and doing this in an imperative manner with the AWS SDK in Boto in Python. On the left here, you can just say, hey, I want a bucket. And when that bucket comes back, I'm happy with that. On the right-hand side, you'll see that I actually have to create the bucket and log the error. That's an imperative operation. I'm doing something with thinking about the consequences, because I have to do that. This is a very simple example. Once you start to add more resources to this pattern, it gets way, way, way more complicated. This is a visual representation of what I'm talking about. So when you create multiple resources in a cloud provider, each of the things here in this particular visualization, A, B, C, D, and E, all represent something in your cloud provider that you are creating. And if you drill this down to something like a networking layer in Civo or AWS, this is actually what it looks like. You create a virtual private cloud, and then you create subnets in that virtual private cloud, and then a NAT gateway to get out to the internet, and then maybe an endpoint that is actually talking to other services in Civo Cloud. These things are parts of a really important mechanism within infrastructure as code called the DAG, the directed acyclic graph. Every infrastructure as code tool that I'm aware of builds these things, every single one of them. And they do this generally by having this underlying representation of what the DAG looks like. And a lot of people do this in a configuration language, and lots of infrastructure as code tools will allow you to use a configuration language like YAML or JSON to build those things for you. And it's really easy to do that because there's not a lot of kind of manipulation you have to do in this DAG. You say, here's what I want it to look like, here's a text representation of it, and this is what I want the end state to look like. The problem is that all those configuration languages are garbage, and they're really, really horrible to write, and they're really, really painful for anybody to actually manipulate. And it gets really, really difficult at a large scale to manage these configurations. And the reason for that is because not every environment that you're going to build is going to look the same. Your production environment and your development environment will have slight differences. They will have slight complexities, and, you know, in most organizations that I've ever worked with, they'll tell you my development environment is really, really close to my production environment. And they're lying to themselves because there's something different. There's something that's not quite the same. And what ends up happening is you want to use the same code between these two environments, and you want to make slight modifications to it. Like you may want to do it in different regions, and you may want to do it in different cloud providers sometimes. And so this is what ends up looking like. You have this production DAG on the left-hand side, and then on the right-hand side, you have this development DAG. All I've decided here is that I'm going to remove a subnet from my development environment because I want it to be cheaper, and I don't want to spend as much money in my cloud provider. This is already creating complexity that cannot be expressed in a configuration language on its own. If you start to layer things on top of that configuration language, you can do it, but then you're in a real world of pain. So what we ended up doing is we created all these domain-specific languages to allow us to represent this. And this is just a off-the-top-of-my-head idea of the ways that you can represent configuration using a domain-specific language. And the job of all of these domain-specific language is to generate configuration with differences in different environments. That's their whole job, is just to express configuration. And the clue is in the name, it's domain-specific. Its only purpose is to generate configuration that you can then send to the cloud provider to express a domain, to express a node graph. And they are varying levels of good. I have used all of them. JSONet is the worst. Bicep is really, really bad. Q is pretty good, but really, really complicated. HCL is very ubiquitous. It's everywhere. I think most people who are in this room will have heard of Terraform. You know, that is very ubiquitous at this point. And DAL is just crazy. So what we end up with here is, okay, we know what we want to do now. We're going to build this domain, this DAG that we're going to send to the cloud provider API. So what do we want the user experience to be when we're building these representations? Well, when you're choosing an infrastructure as code tool, you might Google, you know, a bunch of different infrastructure as code tool names, and you'll usually end up with a table that looks like this. This does not help you make a decision. It tells you the features that exist in all of those different infrastructure as code tools, but it is not going to help you decide which one is best for you. Like, I don't know if having rollback changes is a good thing for my infrastructure as code solution. I don't know at this point, because all I want to do is decide how I'm going to represent the state of the world. So I choose to look at it when I talk to customers who are getting started with infrastructure code. I choose to look at it through two different experiences. How do you want to express that node graph, that DAG? And then once you've expressed it, how do you want to get it into the cloud provider API? And you can drill this down a little bit more to talk about how do you want it to feel when you are describing the state of your infrastructure. And then once you've described the state of your infrastructure, how do you want to actually execute that kind of representation? And there's lots and lots of things here once you get to this level that you might want to think about. Which languages do you actually want to use? Do you want to use a configuration language directly? Do you want to use a domain-specific language? Do you want to use a programming language? How do you want to abstract those things so that you can share them with other people in your organization? What cloud providers do you want to support? Is it going to be a really easy process, or am I going to do it by hand and write it on the back of a napkin? Those are the ways that you kind of want to think about it. And then there's a bunch of different ways that you can actually do this execution, which I'm going to go through. So let's talk about all the different options that you have at your disposal. Here's the different authoring experiences that are available to you right now. The first I already mentioned is a domain-specific language-based authoring experience. And the clue is, again, as I already said, the clue is in the name. A domain-specific language is a single-use thing. Its entire job is to express configuration. So once you get to the point where you want to do something else, you can no longer do that with a domain-specific language. And there's lots of benefits, and in my opinion, lots of cons to this. So the first one is that any investment that you put into learning a domain-specific language is no longer useful outside of that domain. So you can be the world's greatest DAL expert, but once you get to the point where you no longer want to express configuration, you can't build applications with it, you can't help other parts of your organization, you're certainly not going to help the marketing team deploy their website, because that is all it's useful for. That brings you a much lower learning curve on the path to being able to be successful. So because there's less features and there's less expressibility, it's a much simpler process. Once you're in that kind of like domain, the abstractions that you have where you would share it with other people are generally specific to that implementation. So again, it's not reusable, it's not usable elsewhere. These are the DSL-based tools that are available right now. The most ubiquitous and the most commonly known is Terraform. Terraform is everywhere. I have lots of opinions, as you can probably tell, about why that is. But most people are familiar with Terraform as an infrastructure as code tool. And then Microsoft, in its infinite wisdom, decided that it was going to build its own DSL specifically for its cloud called Bicep, which is supposed to be a nice play on words of ARM. And its entire job is to express ARM templates. And ARM is Azure Resource Manager. So these are the DSL-based tools that you have at your disposal now. The other kind of more simple approach is a configuration language-based approach. So this has got a very, very limited scope. And we already talked a little bit earlier about the ability to express a DAG with a configuration language is really not great. Because in order for you to actually do complicated things, you either need to go to a DSL, or you need to build something on top of it to be able to express different things. The fact is that it's really, really simple to get started with a configuration language. I could probably teach most people, even that are getting started in IT, to be able to write a configuration language-based document. That lower learning curve is really, really helpful to getting people started. But it doesn't give you a great authoring experience when you're actually expressing the way the world works, because you don't know until you actually send it to the cloud provider API if you've made a mistake. That's a really slow feedback loop. So it means that you end up kind of going through this process of being like, I'm going to make my infrastructure look like this, or I send it to the API, or I made a mistake. Then I'm going to modify it, or I made another mistake, and that can take you a long, long time, and it can be really, really frustrating. If you've ever used a CI/CD tool, I know the last talk was about CI/CD. If you've ever used a CI/CD tool, it feels like an exercise in hitting yourself in the face, because ultimately it just takes a long, long time to get anything done. But that simpler learning curve is a great thing for a lot of organizations. These are all of the infrastructure as code tools that currently support a configuration language-based approach. Now, you'll notice that there's more on this section than there is in any other section, because adding a configuration language-based approach is a great getting started experience. So Pulumi supports a YAML authoring mechanism. I fought very hard against that, but we did it anyway. Azure Resource Manager, if you don't want to use the Bicep DSL, you can write them by hand. Terraform, if you really wanted to, you can express Terraform in JSON. I don't think I've ever seen anybody do it because they don't hate themselves enough, but it's possible. Crossplane allows you to write cloud provider resources in YAML, and then CloudFormation allows you to write them in YAML as well, or like a JSON type configuration document. So the fact that all of these infrastructure as code tools support a configuration language-based authoring mechanism should tell you that if you are working with people in your organization who are just getting started with infrastructure as code, this is a great place to start. And then finally, the authoring mechanism, which I personally prefer, and which I promised people hot takes, so here we go. My perspective at this point is that almost every infrastructure as code tool will offer a programming language-based authoring model at some point in its lifetime, because it's incredibly expressive. So we talked already about being able to build this DAG, this node graph of different resources. The thing that a programming language allows you to do is manipulate the things that exist in that graph really, really easily. And the fact that those language-based abstractions exist means that lots and lots of people get benefit out of it. It's also way more reusable outside of that particular purpose. If you get started building infrastructure with a programming language, you are learning the core foundations of that language that you can then take to other things within your organization, like fixing bugs or building prototypes or maybe becoming a web front-end developer at some point in your life. You don't get that from a DSL. You don't get that from a configuration language-based approach. The other thing that I think is really, really important is that almost every developer environment will help you along the way when you are using programming languages. I talk to customers all the time at Pulumi who will tell me, I'm having a really hard time with Pulumi because it feels really complicated. And then they're like, well, what are you using to actually write it? And they're like, well, I'm basically using Notepad. And my answer at that point is, well, you are always going to have a hard time. If you actually lean into the language ecosystem will help you express this infrastructure way, way better than anything else ever could. And that's because of the type systems that you have on top of it that will help you get that feedback loop. So you remember earlier when I mentioned, you can write these things in configuration languages. If you use a programming language when you're expressing infrastructure, the type system will basically tell you, you should not be passing that thing here, you should not be using that thing here. That feedback loop is really, really fast. And the way that I like to think about it is when I'm writing infrastructure as code in a programming language, it feels like it's at the tip of my fingertips. And I spent 10 years feeling like I was banging my head against the wall with the API telling me I was doing something wrong, and now I'm getting that right at the authoring time. So again, just to reiterate, I personally believe that all infrastructure as code tools at some point in their life cycle will get to the point where they offer a programming language-based authoring model. It's way more flexible. It's a way better way of operating. And the only reason this isn't really a kind of like considered first-class practice right now is because we're seeing an industry shift in the people who are able to express infrastructure. And I'll talk a little bit more about that in a few moments. So these are all the different tools that I'm aware of right now that allow you to use a programming language-based authoring model to express infrastructure. Pulumi is arguably the first that kind of went down this path. AWS CDK popped up a few months after Pulumi. I can tell you a great story about that over a couple of beers if you like. And then Cloud Development Kit for Terraform also supports this as a way of expressing Terraform manifests with programming languages, similar to the way the AWS CDK works. And because I like diagrams, here's a great visual of what it looks like to choose